Hello everyone, welcome to Code Spy. So till now we have discussed about many topics in Spring AI like prompts, function calling, multimodality, the structured input-output converters. So these are the features of Spring AI, but how it works internally. So to understand that, you have to understand the architecture or layered architecture of Spring AI. So there are total 6 layers in the architecture. So first layer is a client layer where you receive the request from end user. Then we have application layer. In layer 3 we have a Spring AI layer. Then after that we have a model layer. Then after that vector store layer, and at last we have a AI provider layer, which is going to connect to that external models, and it will return the response. So we'll discuss in detail from the first layer, that is a client layer. So the client layer is the topmost layer, and it is basically used by the end users for their query. So there is only one job of this layer, that is it will take the input and it will return the output. Whatever question is asked by a user, it will take it, it will go through a number of layers, and after that it will return the output. The client layer can be like a mobile application, web application, chat device screen, REST application, anything which is available to the end user for their query. So once a user enters their query in the client layer, let's say a user is asking that explain chatbot or explain Kubernetes or anything. So then that message will go to the next layer, that is application layer. So the application layer is going to be your business layer. This is the place where you decide how you are going to use your AI models. So the flow is going to be simple. So let's say user is, asking these questions to a chatbot. So the chat related query will come to the controller in the application layer, and then it will pass it to the service layer. Service layer is the real decision maker. So here we decide. So it will ask questions like, should we use memory? Should we use caching? Should we use token limits or a rate limiter? Should we use function calling for any external operations? Should we use multimodality, or what type of model should we use for that query? So those things will be decided in a service layer. And with that we can implement security also, like we can ensure that the call is coming from the correct user for that query. We can implement rate limiters, we can implement token limits, because as we know that AI models has a limitations to use tokens. The more you use token, the more you have to pay. So after all this business logic, it will go to the third layer, that is Spring AI layer. So this is the most important layer, or we can say that it's the backbone of Spring AI. So this is the place where Spring AI does its magic. And whatever options you see or components you see in Spring AI layer, like chat client, prompt templates, AI advisors, memory management, tool calling, RAG supports. So these things are not used in every model or every flow. Let's say when you're working on chat client or a chat bots, you will not use every feature from that AI layer. So it depends on the requirement. Whatever you want, you can use it on the basis of your requirement. Whenever you're using chat client for any text processing, like you are asking explain microservices to your chat client. So what it will does internally. So first it will build the prompt. Okay, then it will apply advisors. We will discuss advisors later in this video only. So you can think advisors like interceptors or filters, spring filters. So whenever you are sending any request to your models, so between that, if you want to add loggers, you want to handle some security related features, you want to change or improve your prompts, so those things can be handled using advisors. So there are different types of advisors, we will discuss that later. So after applying advisors, it will create AI request, then it will go to the model, then model will process it and it will return the response, and finally it will return the result back to the user. So this is how chat client internally works. Then we have prompt templates. So prompt templates are basically used whenever you want some reusable prompts. Only thing is your structure is going to be same, but response will change. So let's say you are working on some backend integrations, or you're asking some questions like explain, RAG, but the format is going to be same. You're working on, some content writing or something. So format is going to be same, but question topic will change. So those things can be defined in prompt templates. Then we have advisors. So advisors are introduced to help AI models to make, you know, our prompt more optimized, more improved for AI models, so that it can give you more accurate results. And with that, it also helps in other features like security, just to make sure that prompt does not contain any harmful information. We can take an example like you are asking some questions to a chatbot. So that request will go from client layer, and or we can think like that the request will go from the UI to that model. Okay, so request is there, and then it will go to the model. It will go through all the layers, but it will go to the model, right, for the processing or for the response. So between that, if you want to change it, or if you want to update your prompt, then you can take help of advisors. So here advisor will come. Using advisors, you can filter your prompt, you can improve your prompt, you can optimize your prompt. So there are different types of advisors. So first one is like memory advisor. So using memory advisors, it will add the previous conversations to the prompt, so that AI will remember the previous conversations, and it will help models to give you more accurate result. Then we have logging advisors. So using logging advisors, you can log your request which is going to model and the response which is coming from the model. Then we have a RAG advisor. So RAG advisor is basically used whenever you have some external connectivities there, like database is there, and from database there are some similar, relevant information is there related to your query. Then it will fetch the data from the database, and it will add that document to the prompt. So that prompt will learn it more and improvise it, and then it will give you more accurate result. Then we have a security advisor. So security advisor is basically used to save you from harmful text. If it will just make sure that you are not passing any sensitive information and some harmful text which is going to affect the AI models. So those things will be taken care by security advisors. After that, we have a memory management. So memory is also important because AI does not have its own memory. It will not memorize things on its own. Every prompt, every query is new for the AI models. So let's say you are saying, my name is Code Spy to the AI model, and tomorrow it does not have a memory. And tomorrow you are coming and you are asking that yesterday I told you my name. Can you please repeat again? It will not remember because it does not have memory. It will not store it. It will give you that response at the time only. So memory is very important for models to remember the previous conversations. Next we have is a tool calling. So tool calling is nothing but a function calling. So AI also has a limitations. So let's say you are asking questions to AI models that what is the weather of this city or a state. By default, AI will not know the weather of that place, right? But using function calling, you have some external API which will tell the weather of that state or that city or a country. Then it will use that weather API, and using function calling, it will fetch the data from that weather API, and then it will pass it to the prompt. So for that, I have created a very detailed video that is a function calling. You can go and watch that video. Then we have a RAG support. So we have already discussed that we have a RAG advisors, right? So whenever you use RAG advisors, what it will does is whenever user is asking any question, it will fetch that question to the vector database. And if it finds any relevant document or details for that query, then it will attach that document in the prompt, so that whenever it is going to model is able to understand it in more accurate way, and it will give you the more accurate result. After Spring AI layer, the next layer is going to be your model layer. So in model layer, you will decide models related to your query. So whenever a user is asking questions related to text processing or explain some microservices or something, so for that you will use chat model, because those are related to text processing. And chat model will internally use like GPT is there, Gemini, Claude, on the basis of the configuration and the requirement. Then for image processing, it will use image related model. So in this layer, we'll decide what models we are going to use. So after a model layer, it will go to the next layer, that is a vector store layer. This is a special kind of database which is created for AI. So in normal databases, what happens is whenever you are asking any query, if the exact match is available, then it will return the response. But in vector database, it returns on the basis of similarity. So here it works on the basis of more approximate results or a similar result. Whenever we are working on any models where we need, RAG ingestion, semantic search, in that cases we can explore vector databases or integrate vector layer. These are the some options whenever you are integrating with vector databases, like you can use PG vector, Redis vector, Elasticsearch. So after all these layers, the next layer or our final layer is going to be AI provider layer. So till now we have not invoked AI models for the response. Till now we have worked on prompt building using different techniques in different layers. Now it's time to invoke AI provider layer or actual AI models. So here it is going to call the external infrastructure like on the basis of your configuration, like OpenAI, Gemini, Anthropic, and then it will return the final response to the end user. This is the kind of full picture of Spring AI, what it can do internally. So that's all we have with Spring AI architecture. And if you want me to do some hands-on any of the layers or any of the step, please do comment. I will create a separate video on that. And if you like this video, please share it and subscribe my channel. See you in the next video. Till then, goodbye.